In this video, we'll prep for finding the zeros of polynomial functions. Specifically, we'll look at a review of synthetic division. Now, the synthetic division won't really help you find the zeros of the polynomial functions, but will help you verify if a number is a zero or is not a zero of a polynomial function. So let's review a synthetic division problem. If we're to divide x to the fourth minus 3x cubed plus 2x minus 5 by x plus 2. So remember, when you're doing synthetic division, you're saying, okay, if you divide by a binomial of the form x minus k, where k is a number, that in this case our k would be negative 2. So we'd put our negative 2 on the outside. And then what would go inside the box would be the coefficients of the polynomial that you're dividing into, the dividend. So in this case, the coefficient of the x to the fourth is 1. Coefficient of the x cubed is negative 3. Now there is no x squared, so remember what you got to do for any missing powers, you put in a 0 in its place, because you could think of it as plus 0 x squared. And then 2 is the coefficient for the x, and our constant is negative 5. And then when you're doing your synthetic division, the next step is to bring down the first term. So bring down the 1. Multiply the negative 2 times the 1, so you get negative 2. You put it in this space here, right below the value in the second column. So, and then add those two values. So negative 3 plus negative 2 would be negative 5. Then you multiply the negative 2 times the negative 5, so you get 10. So you put that in the third column, right below the 0. Then add those two values. So 0 plus 10, that'll be 10. Then negative 2 times 10 will be negative 20. Add, and you put that in the fourth column position. Add those together, so 2 plus negative 20 will be negative 18. And then negative 2 times negative 18, that'll be 36. Add those together, you get negative 5 plus 36 will be 31. Now remember, this 31 represents the remainder. So that's the remainder. And the values to the left of it are the coefficients of the quotient, and they go from right to left in ascending power. So the negative 18 is your constant, the 10 is the coefficient for the x term, negative 5 is the coefficient for the x squared term, and the 1 is the coefficient for the x cubed term. So that means in this case our quotient would be 1x cubed, so x cubed minus 5x squared plus 10x minus 18. Now, one thing to remember, what the division algorithm states is that when you divide your dividend by your divisor, that's equal to your quotient plus the remainder divided by the divisor. So in this case, that means that we have x to the fourth minus 3x cubed plus 2x minus 5, all of that divided by x plus 2 is equal to our quotient, that x cubed minus 5x squared plus 10x minus 18, plus our remainder, which was 31 in this case, divided by our divisor, so that'd be x plus 2. Now, what will be more useful in this case is if we take that dividend divided by the divisor equal to the quotient plus the remainder divided by the divisor. If we multiply both sides of that by the divisor, so we multiply each term by the divisor, then on the left-hand side, well, we would just have the dividend is equal to our quotient times the divisor plus, and then we would just have the remainder. Now in this case, for this example, that's telling us that x to the fourth minus 3x cubed plus 2x minus 5 is equal to our quotient, that x cubed minus 5x squared plus 10x minus 18 times our divisor, the x plus 2, plus our remainder, so that'll be 31. Now, how this will help us to verify if a number is a zero, the polynomial, is, let's say in this case, this is again a preview of when you're doing the zeros of polynomial functions in the college algebra class. Now let's say if this, our dividend was our f of x, and we wanted to know, is negative 2 a zero? So you could plug in negative 2 into the function, but sometimes if it's a really big polynomial, that can take time to do. And synthetic division is actually quicker than it is to do evaluations by plugging in the value. Because if this was our function and we plug in negative 2, well, what that would equal to is, well, this quotient times the divisor. If we plug in negative 2, the main thing is that negative 2 plus 2 from the divisor, that'll be 0. And then plus 31. So whatever we get when we plug it into the quotient, it'll still be times 0. So that'll be 0. So that'll just equal to 31. So what it turns out is that the value that we get when we plug in negative 2 into the function is the same thing as the remainder when we divide by x minus that number. So that's going to be the way it'll be helpful for you to verify if a number is a zero of a polynomial function. And so to do that, you got to remember how to do your synthetic division.